All right, so today we'll take a look at kind of the last data structure. So we've covered things like lists and tuples and strings, and then there's one more, and these are the dictionaries. What's going on? Okay, and dictionaries are basically pairings of keys and values. Okay, so in R you had something similar. You could take a vector and you can name it, and then you could reference items in the vector via name. Dictionaries are similar, except you can actually mix up the kind of values in there. The normal way is you use curly braces to say I'm going to make a dictionary, and then you use a colon to associate a value with a key. Okay. Now here I have the value, the key being a string and the value being a number or an integer in this case. It doesn't have to be that. You can associate strings to strings and other stuff. We can play around with this. Okay. So this will create a dictionary. And here, actually, let me just type out people. Okay, and then here's what the dictionary looks like. Now, coincidentally, the order that I've defined them here is the order that they appear here, but this is not necessarily the case. You might write the dictionary out in a certain order, but then when you print it out, it comes out in a different order. Dictionaries are inherently unordered. You can't sort a dictionary, you can't do stuff like that. They are inherently unordered. Okay. You can also create a dictionary by zipping two lists together and then throwing that into a dictionary. So here I've got a list of the names, Adam, Bob, and Carl, and I've got a list of values, which is like their age, okay, ages. And then you zip them together. If the result of the zip object is a zip object, okay? It'll say zip at this memory location. This is just output of a zip object, zip function, okay? But if you throw that inside a dictionary, then it will produce a dictionary, and indeed you can check, is this dictionary up here equal to this dictionary that we just created using the zip function or zip feature. You can it is, okay. And then once you have a dictionary, you just use brackets and then the key to pull up the value associated with it. I'm just kind of curious. I'm going to just create a new dictionary here. And I think so here I'm creating a dictionary, and I can reference so you can associate this key, the key 2, to the value 20 or whatever it might be. You can even associate it to like a list, 20, 4, 5 or something like that. Okay. And then so it's just you take one object and another object, whatever it is, and you just associate them with keys and values. Okay. So keys can be numeric, objects, values can also be lists. Okay, you look one thing up and find the other thing. All right. Dictionaries are inherently unordered, so you can't use numeric indexes like the traditional way. Okay. If you provide a number, that number needs to be one of the keys. So going, if I say people 0, it's not going to give me the first item in the dictionary. There needs to be, if there was a person named 0 or whatever, if 0 is one of the keys, it would work, but here it says key error, there's no 0, basically. Okay. Okay, so here's our current dictionary. It's got Adam, Bob, and Carl, and you can use the key mapping to create new entries in the dictionary. You can also use it to modify any of the values that are in there. So here I can just say people Derek is equal to 33, and that will create a new entry because Derek doesn't currently exist. New entry. And this is modifies existing key value pair. And we can say, oh, Adam's age is actually 26. So we do that. And then if I ask to print it out, then indeed Adam has changed to 26, and Derek now appears in the list. Okay. If you want to remove a key, you can use delete. All right, and then so here I'll say delete from the people, Carl. Okay, and then when we print out people, gives back the dictionary without the person I deleted. Right.
Is there a pop function?
There is a pop function. Oops. Let me see. But you have to specify the key. Okay, you can't because dictionaries are unordered. You can't just do pop people. Okay, this will return an error. Oh no, I'm sorry. It's going to be people.pop. So this will return an error, but people.pop, I can say pop Adam, all right? So this returns the value for Adam, and if I say print people, now it's what's remaining because we've popped Adam out of the dictionary. So there is a pop method. But it requires, pop method requires a key that exists in the dictionary. Yes?
If you gave it the index, would it pop name?
Yeah, so again, if I try to pop like index 1, all right, it's going to say that key doesn't exist. Okay, so dictionaries do not have an index. That's an important distinction. If it feels like there should be an index, but dictionaries don't have an index. Okay, dictionaries are inherently unordered, and so there's no index for the dictionary. Let me just for the cell, let me tag this with raises exception. Okay, so in a Jupyter notebook, if one of your cells causes an error, it's going to halt the notebook, and everything after that cell is not going to execute unless you tag it with raises exception, and then Jupyter will allow that, and it will continue running. Like if you do something like kernel restart and run all, it'll do that, which is useful for like teaching. Okay, but normally you don't want to have errors in your notebooks, right? But in teaching, it's good to say like this is going to cause an error. Okay, so those are dictionaries. There's stuff you can do with a dictionary. There's something called a dictionary view object. Okay, and it's these things: dictionary keys, dictionary values. So the keys are associated with the keys, the values are associated with values. And the dictionary items is gonna be everything in the dictionary. Okay, so here is let me redefine people. Let's just throw some stuff back here. Okay. Okay, so here is people. It's got Adam, Bob, and Carl again. Adam 25, Bob 19, Carl 30. Okay, and then and I can create these dictionary view objects. All right, I'd say people.keys. I'm going to just assign that to names. People.values will be ages. Okay, and when I say print names, it's going to say it's not a list. It's a dictionary view object. It looks like a list, but it's not. Okay, it'll say dictionary keys Adam, Bob, Carl, dictionary values 25, 19, 30. Okay, so the thing about the dictionary view objects is that they are dynamic, meaning here I'm going to create a new person, a new entry in our dictionary. I'm going to say people ed is equal to 40. Okay, and then without needing to redefine names or anything, if I say what's in print out the names, the dictionary view object for the keys is modified and it now includes ed. Okay, so this object names is dynamic, in it whenever the dictionary gets modified, this object names also modifies. Okay, same with the ages. Okay, as soon as I just ask, what does ages look like, it includes the new value 40 in there. Okay, there's only a few functions that these view objects support, but they're basically what you would want to use. Okay, one is the length, how many what's the length of ages, and then there's another function in. Okay, does a value exist in the thing? And so again, if I if we create someone new, so here, so anyway, there's length and then there's in. Okay, if you want to like make use of it, you can turn the ages into a list. Okay, so likewise, dictionary keys also inherently unordered, and dictionary values are also unordered because they are view objects of the dictionary. So you can really only check, like, does a certain entry exist in there? What's the length of it? But you can't say, like, I want the fourth item in dictionary keys, because the dictionary is unordered, so it doesn't make sense to talk about the fourth item. Okay, if that frustrates you, you can take the view object and throw it into a list, and it will produce a list with all of those things. Okay, and then you can sort it and ask for the fifth item and things like that, but you've now lost the dynamic feature that the dictionary view object has. So for example, right now when I ask for ages, it's the dictionary view object 25, 19, 30, and 40. Okay, here I can ask to take ages and make a list, and when I print that out, I get a list with 25, 19, 30, and 40. Okay, and so now that I have a list, I can sort it, I can ask for the third item, I can ask for index 0, things like that. Okay, lists are ordered, you can reference them by index. Okay, here I'm going to add another person to the dictionary. I'm going to say we're going to add Frank 29. And then, and if I ask, what about ages, the dictionary value for ages updates, that is dynamic, but the age list itself is not dynamic. Okay, so it doesn't include Frank's age of 29. Whereas the view object, ages, is dynamically updates with the dictionary. Okay, and so if you have something that modifies dictionaries, or is adding or popping things out of the dictionary and deleting stuff, you can always kind of check, is this inside the dictionary, or is this inside, does this value exist within the keys, or does this value exist within the values, or things like that. You can always check for that using one of the view objects, which is a nice feature of dictionaries, okay? Is that all right? Questions on that? And so a lot of complex stuff in Python is powered by dictionaries. I guess we're just introducing these structures here, and maybe I'll have to find some examples. Okay, let me now we'll start talking programming stuff, and we'll do flow control. So I think most of you guys are probably familiar with a lot of these concepts and topics, but we'll just kind of cover them quickly here. So we have if, else if, and else, right? Else if is elif, and they only get executed when the if statement is false, right? So as far as syntax, okay, in R you got to get used. If you're coming from R, which many of you are, you're always accustomed to writing parentheses after if. There's no parentheses after the if statements, okay? No curly braces. You write if, you write this conditional statement, and then a colon, okay? And then you have to indent, put in the stuff associated with that conditional, and then you indent back out, okay, back to the first level of the if, and then and those things, and then you indent there, okay? So so it would look something like this, okay? So here x is -3. We check, is x 0? Is it positive? Is x greater than 0? And then we would say print x is positive. And otherwise, x must be negative. And in this case, indeed, it says -3 must be negative. Okay. No surprise there. Okay. And just like anything else, if the if statement is executed, the else if or the else will not be executed. So here x is equal to 100, and I've got if x is greater than 100, print x is positive. Else if x is greater than 3, print is greater than 3. This is not going to be executed because the if statement is true. So everything else will just get ignored. Yeah.
So you can't just use else if and else by themselves. You need to use if.
Yeah, you can't use else if by itself or an else by itself, because there needs to be something if, right? Yeah, I mean, it's kind of like English also, right? The else doesn't make sense unless there's something that says this needs to happen first, right? Okay, so those are your conditional statements, which I think we're used to, okay? And then just like other things, we've got loops, okay? So you can use a for loop to iterate over some kind of iterable object. So I've got list, tuples, range, even strings are iterables, which is kind of neat. Other things. So here's a list. Okay, 5, 7, 2, 1. We're going to start with y, set y equal to 0, and I'm going to say for x in values. So values is the list, and x will just be each object in this list. Do this thing. We're going to print out the object, and then we're going to update y by doing y plus equals x. Okay, and if you haven't seen plus equals, this exists in many other languages, and it's basically shorthand for y is equal to y plus x. All right, so you just take your current value of y, and then you add x to it, and you update the value of y. And so, so here, when you run it, it's going to say, okay, print x 5, running sum is 5, 7, running sum is 12, and there you go. Let me see. Oops. So we have that. Let me just do like for A in abracadabra. Okay. So here it's a string, and you can say print A dot upper plus exclamation point here. It makes more sense. We'll do UCLA, all right? And then when you do this, now you got the start of a cheer. Okay. And so so you can iterate over strings too, which is kind of a neat thing. So okay.
You add a space.
Probably UCLA. Let's see. Yeah, you get a space. It'll do it. So I don't know what this is. I guess this is the clap or something. Okay. I mean, and this is silly, but there you go. Okay. The range object kind of takes place of, so in R, oftentimes you'll say like for I in like 1 through 1,000 or something like that, 1:1,000. In Python, you would do the same thing, except you'd use the range function. And so range 10 would be pretty much equivalent to saying 0 through 9, meaning it's going to create a range of indexes that are 10 items long, but starts with index 0. The general format of the range function is start and end with step size, unless you provide it just a single integer, and then it'll default to 0 through that integer. Okay. It'll start at the start value. It increments by the step size, and it goes up to, but does not include the end value. Okay. So you have range 10. This is the same as range 0, 10, step size 1, okay? And so here we have for I in range 10, print I, and end is basically the end of the print argument, and here I'm saying use a space. The default argument for print is a new line character, so if I didn't specify this, it would print to new lines, right? Just like up here. Okay, and so there we have that. Yes?
If you wanted to make a list with range, would you need to do it through a for loop?
No, you can just throw it into a list. Yeah, exactly. So yeah, when you ask for a range object, right? You're like, I wanted the numbers 0 through 9, okay? Or if you say like range 5, 10, and you say I wanted those numbers, you can throw it into the function list, okay? So it returns a range object, which can sometimes be a little bit frustrating. But if you want it as a list form, it's no problem. You just throw it into a list, and you get it, okay? And likewise, so here's range 0, 20, 2. It's going to range from 0 to 20 by 2, going up to but not including 20. Okay. Here, let me just do range 0, 20.1 to. Oops. Oh no, it doesn't like that. Okay. Float cannot be interpreted as an integer. All right, so that gives you an error. 21 will include 20. Okay, 20.1 apparently kicks back an error. I'll leave that in here. So yeah, when I teach, you have to kind of purposely think of silly scenarios that break the computer. Okay. Okay, so that's those are range objects, and so those are very common, just like in R, because a lot of your loops you'd say for I in 1 through a billion, so now it's going to be for I in range a billion. Okay, maybe not a billion, for I in range 1 million or something like that. Okay, with while loops, it'll run until the condition is false. I think we're familiar with this. So here I have to say I is 0, while I is less than 10. Print I. Don't go to a new line, and then increment I by 1. Okay, so not a big deal. All right, and then as soon as it hits 10, it quits out. Right. All right, and then and you have break and you have continue, much like in R we had break and next. It's like this. So continue will just skip the remainder of the loop. So here the for loop says all of these lines are associated with 4, and this continue, because it's at a second level indent, is associated with this if statement. Okay. So we're going to say for n in range 20, so it's going to start at 0 and go through 19. And we're going to say if n modulo division 2 is equal to 0, so meaning if it's an even number, continue. So we skip the rest of the loop statements, so we're not going to do the print. And then we go to the next iteration, and we get 1, and so on and so forth, and it prints out all of the odd numbers. Okay. Here's some code. Okay. So this uses you can assign multiple values, I guess, using tuples. All right. So here I'm going to start with A and B. And we're going to set A to 0 and B to 1. And then we're going to say the maximum value of A is going to be 100. And we're going to start with an empty list, L. And then I write, here I've got a while true loop. Okay, a while true loop will run forever. Okay, because while this is always going to say, let's keep running. And so while true loop will run forever until it hits a break. Okay, and break is the only way you can exit out of this, right? So here we're going to say assign B to A, and then to B assign the value A plus B. Okay, and then and then at the next loop, you'll take B and assign it to A, and then assign A plus B to B. Okay, and so that you're going kind of pairwise for the Fibonacci sequence. And then we're going to say if A is greater than A max, then break out of the loop. Okay. Otherwise, append the value A to the list. Okay. And so L dot append, this modifies the list in place. Okay. I don't have to say L is equal to L, combined with A or something like that. I can just do L dot append, which is nice. And then we'll just at the very end of everything, we'll print out what L looks like. Okay. And we have the Fibonacci sequence, right? Yes.
Is it this while just as like if I use while A small or equal to A max, then what is something?
Yeah. We could have done that. I was just illustrating the use of break. Okay. But yeah, certainly we could have done while A is less than A max. Okay. Instead of having, yeah. You don't have to use a break statement. Okay. Yeah, this is probably not the best way to write the loop, but here we're just needed an example to use break, right? Okay. All right. Okay, and I don't know, other loop stuff. So we got for loops and while loops, and that's basically it. So I get, in R you had the repeat, but the repeat is basically a while true. Okay. Okay, and then now we'll talk functions. Okay, so you call a function with parentheses. So here, if you say, if you write print without any parentheses, it doesn't call the function. It says, oh, you're talking about function print, okay? Which is fine, because I am. And then if you say you want to print something, then you print out whatever it is. Okay, print hello. Print the values 1, 2, 3. And then, you could specify optional arguments like use a dash for the separator and stuff like that. Okay. You can always ask for help. Help print, and it gives you all of the options. Okay, so print values ... meaning like it can accept a bunch of these values, and then you've got optional arguments, the separator and the end, and then file for where to store this, right? So sys standard out just generally means put it out onto the screen. This part where it shows up here, okay? But here you can there's optional arguments to do this, right? And then the other option for help is you do the question mark for this, and then it prints up the this is called the pager, and it's like this little, just a help screen that pops up, okay, with the exact same information. So if you don't actually want it to appear. Okay. Okay, to define a new function, you use the statement def for define, okay, and define, and then you write the function name, and then the arguments, right, and then and there you go. So and the function needs to use return to return an object. So here I'm going to create a function called shouting. It takes in the argument phrase, and what it's going to do is going to make the phrase uppercase and add a bunch of exclamation points, and then whatever you put into shouting will come back as a very excited version of it, right? It's funny how the effect of capitalization and punctuation has on like the inner voices that read the text, right? So this sounds like a normal person, maybe a meek person, and this sounds overly excited, but there you go. Okay. If I put in something that it doesn't work, right? It throws back an error. It says int doesn't have an attribute upper, right? And so I mean, there's a few things you can do. I can just redefine shouting, and I can just try to force phrase to be a string. So whatever phrase is, I can throw that into the argument string, and this will attempt to convert whatever the object is into a string. Okay, so attempt to convert the input object to a string. Okay, so then if I put in 5, we get that. Whoops. But then, if you put in weird stuff, like a dictionary, colons, sorry. you know, this is not whatever this is, right? I'm really excited about this dictionary. Perhaps this doesn't make sense. I mean, this is the stupid function of just capitalizing everything and adding exclamation points. So, okay. Nice thing or a feature of Python is that your functions are able to return multiple values as a tuple, okay? So you can clump everything into a single list object and return the list, okay? Just like in R, if you wanted to return multiple values, you could clump them together into a list and return that list. But here you can actually return, these values as a tuple. So here I've got powers of. I'm going to define this function powers of a number, and it's we've got the square. So we raise it to the second power, we raise it to the third power, and it will return the number, the square, and the cube. So when I call powers of on the number 3, it returns the tuple 3, 9, 27. And the thing about tuples is you can then just say x, y, and z are equal to the output of powers of 3. Okay? And then you can, each object by themselves is, I could say, just what's z? And it'll tell me that it's x, y, z, right? So the objects now exist separately, okay? You don't have to, say list subset 0, list index object 0 is going to be assigned to x, and list, index 1, it goes to y. You can just say, well, I know powers of 3 returns 3 objects, and I want to capture all 3 objects separately. And you can do that, okay? Or if you wanted to, nothing says you have to. Okay. So you can take this, and then J itself will be you can capture it as just one object, okay? You don't have to capture it as 3 objects, okay? You can just capture the single tuple, okay? The tuple as a single object. So that's allowed also, okay? So here you can, so the function returns 3 objects, and you can capture all 3 objects separately, or you can just capture it as a single object, and it'll be a tuple of 3, and you can subset it likewise, okay? What's not allowed, okay, is to just say, like, I only want 2 of the objects. G and H will be powers of 5 or something, okay? This will kick back an error, okay? Because it's saying, oops, powers of, okay? So it says too many values to unpack, expected 2, okay? So it's expecting only 2 values because you said assigned to G and H, but then the powers of function returns 3, and so you get a value that says there's too many values to unpack. And I don't know how to do this, okay? So this is not allowed, is a mismatch between values to assign and values returned. Okay. Is that okay? Powers. So this the tuple unpacking is not allowed. Okay. And then I guess just enough time. And then just like in R, you can specify default arguments. And if you don't, so here is just a very simple function. It takes in 3 arguments, A, B, C, and it's going to print back A, B, C. All right. So it's expecting 3 arguments, and if you don't provide it 3 arguments, it's going to complain that it didn't get the arguments that it wanted. All right. Whereas here, you just specify the defaults inside the definition of the function, okay? and if you call it without specifying any arguments, it'll use the default values. And then, of course, if you actually specify a value, then it will go into the place of the first argument, okay? Or you can explicitly say, I want argument B to take on the value 4, or, you know, I want to use the values 5, 10, and 0, okay? Here is an example, though. So R was smart enough to like try to do all the assignments, and then like anything that wasn't associated with an argument name, it would figure out. This actually throws an error in Python. So here I say call junk. So junk expects the arguments A, B, and C. And here I say junk 5, comma, A equals 10 and B equals 0. Okay? This causes Python to get confused because it thinks it's getting multiple arguments for A, okay? Because it sees this 5 and it says, well, it's in the first place, it's going to be argument A, and then I say, no, A is 10, and then now Python doesn't know what to do, okay? So this kicks back an error, but you know, if I specify the arguments out of order, as long as they match up appropriately, Python is happy, okay? So here I got C is 5 and A is 10, then Python is happy there. Okay. I don't know. Are there questions on this? No, we're good? Okay. All right. Well, I think that's good. You guys seem to be doing well on the data camp and stuff as far as keeping up with the homework, so that's good. And yeah, there's more stuff. We got a lot of Python stuff to talk about, and then we'll eventually get into other stuff like NumPy and Pandas, which is important. So.